Hey guys, you need your proofs practice notes out, but also before we even begin that, we're going to be checking the homework from yesterday where you just had to state if they were congruent and then what the theorems were if they were indeed congruent. This is again the list of this week. I'm gone today and I'm gone tomorrow, and what's due. It'll pop up at the end of the lesson as well if you'd like to take a picture. It is also on the board. Honors Geometry is the bottom row on the chalkboard on the far side of my room. It's also on my homework board and on Google Classroom, so if you ever have any questions, you should be able to figure it out there. So we are on Tuesday. We have two things we're going to do. Well, three if you count. We're going to check the homework from yesterday, and then work on the notes, and then start the homework assignment that is due on Thursday. So you're going to go ahead and take out the homework and switch it with someone around you. And then make sure you put graded by at the bottom. You need to be grading in pen. You may not be grading in pencil. Specifically red pen, purple is fine, green is fine, but when you grade, the attempted but incorrect are -1 from 100, and then if they skipped any problems, it is -4 per problem they skipped. Your sub can pause this video, but keep in mind that angle, angle, side, if they wrote side, angle, angle, it is the same thing. But the others, it does matter the order. The only answer for angle, side, angle is angle, side, angle. The only answer for side, angle, side is side, angle, side, and the same thing with hypotenuse leg. But again, they could have reversed the letters and done side, angle, angle. It is the same thing. But they're -1 or -4 if skipped. When you're done, you can trade it back to the owner for them to look over, and if you have any questions over any of them, you can circle them so that we can go over them when I get back. But you're going to pass them forward and turn them in to the sub. Again, you can pause to accomplish that. Once the homework's turned in, we're going to go ahead and start the notes. You need a pencil, and I actually would recommend 2 highlighters. So 2 highlighters. There are some things to remember from yesterday before we begin. Triangle congruence, there are 5 theorems, and they deal with sides being congruent to sides and angles congruent to angles. Some things to remember that won't be marked congruent, but that you can understand and mark it congruent because it's congruent. The reflexive property, when you have 2 triangles that share a side, that side is not going to be marked congruent on the triangles because it's understood that a side is congruent to itself, so you can remember to mark that for yourself. Vertical angles will also not be marked congruent. Vertical angles are formed by 2 straight lines. They are across from each other. They're understood to be congruent. They will not be marked congruent in 2 triangles, but you can mark them because we know they're congruent. Another is that when you see parallel lines, you want to look for transversal relationships. Transversal relationships. So alternate interior is a popular one. Alternate interior. And then the other one that you might see is corresponding. Remember that corresponding are in the same spot at their intersections. So the one I highlighted in blue, top left, top left. Those are really the only 2 that you'll see the most. I don't want to say you'll never see any of the others, but I would say 98% of the time you'll see these 2. And then last, this is new, whenever you see the word bisect, you need to know that the segment was cut into 2 congruent halves. So if I said that AD bisects, what letters? BC, that would mean BC was cut into two congruent halves. So you can know that, the two pieces are congruent to each other. So that's a little new, but, we've been talking about the word bisect since chapter 1. But we'll find ourselves on the front of triangle congruence proof practice. You've got all that room in the bottom. You can use that room to review the theorems. The first one being HL. HL stands for hypotenuse leg. Hypotenuse leg. And will look like this. Hypotenuse leg, H, is for hypotenuse. It is located across from the right angle. So you got hypotenuse marked congruent to a hypotenuse, and then a leg marked congruent to a leg. So we got AB marked congruent to EF. So that is hypotenuse leg. It only works for right triangles because hypotenuses are across from a right angle. Then you have side, 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 which says that three sides are congruent to three sides. I know in my picture it's really small, but they've got these tick marks that show that each side is corresponding and congruent to another side. Then you have side, angle, side, where your angle is in between, your congruent angle is in between your two congruent sides. So side, angle, side. It does have to be between the two sides. Okay. Then you have angle, side, angle. So again, the side has to be between the two angles. And then last, you had angle, angle, side. So the side is not between the two angles. So there's our example. We're going to decide at the top of the page, we're going to decide which congruent statement we would use to prove the triangles are congruent. So in the first, we've got a side congruent to a side congruent to a side, and a side congruent to a side. So because three sides are congruent to three sides, that would be the side, side, side theorem. Side, side, side. In the second, I did not get these pictures off of our book, but if you see this X, I think that's its nice way of saying that is a side they share. So you can call it a congruent side. It's also really small, but you can see it on your page better. You've got an angle marked congruent to an angle, and then last you've got a side congruent to a side. So if you compared the left triangle to the right, we have two sides and an angle. The angle is in between the two sides, so this is side, angle, side. Number 3, so we're comparing the top triangle to the bottom. We've got an angle marked congruent to an angle marked congruent to an angle, oop, wrong one, and then a side marked congruent to a side. So from what they gave us, we have angle, angle, side, but there's also an understood side they share. So you technically could write angle, side, angle also. So you have a ton of information. But I think they were wanting us to write angle, angle, side because that's what they gave us in the beginning. But because of that reflexive side, you could also say angle, side, angle. The next one looks like we've got a side marked congruent to a side. Oop, nope, that's an angle. Derp. Angle marked congruent to an angle, a side to a side, and an angle to an angle. So you have two angles and a side. You need to ask, is this side in between your two angles? And it is. So it is angle, side, angle. And then last, we've got a side congruent to a side congruent to a side, and then again they put this X. It's because this is the side they share, and I think they're just trying to help you. So you have three sides congruent to three sides. So the only one that we didn't have in those examples was HL. So anytime you see a right triangle, you want to ask yourself, is it hypotenuse leg? And then go from there. But we're going to talk about proofs. Proofs. So you're ready to go to the next page. Just highlight at the top this important phrase. Just remember that you cannot use angle, 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 or side, side, angle to prove triangles are congruent. They don't exist. So make sure you remember that. But here's what it's asking for when you set up a proof. You're going to set up 2 columns. You're going to have statements on the left and your reasons on the right. So statements look like segment blah blah is congruent to segment blah blah, or it'll look like angle blah blah is congruent to angle blah blah. And then for your reasons, I kind of gave you an outline of what you do. It's similar to how you would write a paper. So the first thing you would do is an introduction, and in this introduction you're going to write the givens. So go ahead and write that down in that first box. You would intro by writing the list of givens. So again, what that would look like is something is congruent to something. And then our reason would be, there's a list of, it says given at the top of a proof. And then, as many givens as there are is how many you'll write. If it then said that angle blah blah is congruent to angle blah blah, you'd write that as a given. But that is what you would write first. So just like in a paper you introduce the paper, you're going to introduce your proof by using what you were given. The second thing is the body of the proof, and you're going to use properties and theorems. Properties and theorems. Properties and theorems. So for this section, that would look like things that are not given to you, such as vertical angles. So if you had a picture, with vertical angles, you would say angle blah blah is congruent to angle blah blah, and your reason would be vertical angles. The same thing if you had a reflexive property. If you saw that BD was congruent to BD, then you would write reflexive property. So that list I showed you a little bit ago. What else did it have? It had the parallel lines and the transversals, so like corresponding angles, that kind of thing. But that's what goes in the middle. And then last is your conclusion, and it's what you are proving. So triangle in this section, triangle blah blah, is congruent to triangle blah blah. And our reason in this section will be one of the theorems. So like angle, angle, side, angle, side, angle, side, 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 angle, side, or hypotenuse leg. So the very last thing you write is what you were trying to prove, and then, what theorem you used to prove it. So you've got the givens first, your properties and theorems second, and then what you're proving is third. And we are going to practice here. So they already filled it in for us, so we're just going to use that. But first, this is a very confusing picture. So go ahead and take one highlighter and highlight FRY, triangle, FRY. And we're going to highlight it on the picture as well, triangle FRY. Take your second color, highlight triangle FLY. So now you know which 2 triangles we are looking at. And then we're going to mark the givens just in the picture. We're going to deal with the proof at the end. The proof is really the last thing you do. But we got angle YLF, YLF. So don't outline it like I did, I'm just showing you. L is the vertex. So when we say YLF, we're saying this angle here, YLF. And then is congruent to FRY. Again, R is the vertex, so FRY would be this angle, FRY. So that was the first thing they gave us. The second is RFY. Remember, F is the vertex. So RFY would be this angle, RFY. Is congruent to LFY. F is the vertex, so LFY. This angle. Really, we should have two arcs. Sorry. LFY. One arc means that they would be congruent to the first two as well. They're not. They're congruent to each other. So this is our picture. What I recommend before you even start is to decide which theorem first. So we're going to decide which theorem proves these two triangles are congruent in the first place. So in our first triangle, we got an angle marked congruent to an angle. And then again, we have a second angle marked congruent to a second angle. And then last, it's not on the picture. We know they share a side. So they have a side that is also congruent. So we're going to decide which theorem this is. We have two angles and a side. So we need to decide, is it angle, side, angle, or angle, angle, side? And I would say angle, angle, side. The side is not in between. So I'll show you why deciding what it is first is helpful, especially when you're doing it on your own and you're not filling in the blanks. But if you see here all the statements, the things are congruent, and then we're going to write in the reasons. So starting, remember, with the introduction, they said YLF is congruent to FRY. You should remember that from the beginning. This is a given. So we're going to write given as our reason. We know they're congruent because they literally told us they were congruent at the beginning. The second thing they wrote is angle RFY is congruent to angle LFY. Again, they told us that at the beginning, so that's how we know. So given. Those are the only givens we have, so we move on into the second part, which is the body of our proof. And here's why deciding what theorem you're using is helpful. If we did not know this next statement, we have an angle marked congruent to an angle. We had our angle marked congruent to the angle. So the last thing we're missing of angle, angle, side is that side, that was those sides that were congruent. So it says that FY is congruent to FY. So we had already marked that congruent. That's why it's helpful to figure out in the first place. We marked it congruent because it's congruent to itself. That is called the reflexive property. So the reflexive property. So we started with our introduction. So our intro again was our givens. And then this one was really small, but the middle part is always like the body, like the theorems you use. And then the last part is your conclusion. So it says triangle FRY is congruent to triangle FLY. And then our reason was angle, angle, side theorem. That was our reason. So that is our first example. Find number 7. Number 7 is the next one we're going to do. So again, the first thing you want to do is go ahead and decide what theorem you have already. So we're going to fill in our givens to figure that out. So we got LT is congruent to TR. Angle ILT. L is the vertex, so it'd be this angle. ILT is congruent to ETR. So T is the vertex. ETR. And then this last one, this is the more complicated. It says that IT, and I would mark if you don't remember what those lines mean. It means parallel. So anytime you see parallel lines, you want to think we have a transversal, because we do. A transversal is one line that touches two or more lines. So if we need to figure out, we know that IT is parallel to ER. So if they're parallel, you can put a little triangle. Parallel means they will never intersect. It does not mean they're the same length, so don't mark a side as congruent. They're just parallel. So we want to figure out what side is touching both of these sides, or what segment is touching both of these sides. And I would say it is LR. If I drew off to the side, this is what we're looking at. It's harder to see because I know with our whole chapter of transversals, the lines kept going, they weren't segments. So if you don't like the way it looks, you can extend the lines just to get a better look and figure out what you can see. Here, there are no alternate interior, because remember, you want to be thinking alternate interior. Alternate interior would look like this. We don't have that, because interior would be inside of our double lines. So this angle is inside, and this angle is inside, but they don't have an alternate interior with it. But what we do have is corresponding. Corresponding are at the same spot at their intersection. I know this one is harder. I really, really do. We can practice a ton of them when I get back. You don't see corresponding very much, but I'm telling you, the corresponding, they are both in the top left of their intersection. So at their intersection, they're both in the left. So this angle would be congruent to this angle. So again, don't be freaking out. I know you're looking around the room and you're like, corresponding angles, what? We're going to practice, I promise. This is just the introductory lesson. Our main goal right now is focusing on how to fill out a proof and how to go from there. Okay, so again, before we even start filling out our proof, we need to decide what theorem we have. We have an angle marked congruent to an angle, a side marked congruent to a side, and then an angle marked congruent to an angle. So is it angle side angle or angle side? And it will be angle side angle just as it's written, because the side is in between the two angles. So that's perfect. So why does that help me? In our reasoning, in our statements, we need to have eventually stated that our two angles were congruent, our sides were congruent, and our angles were congruent. So we'll write that as we go. But we have LT is congruent to TR. That was a given statement. Remember, they'll always start with the givens. Angle ILT is congruent to angle ETR. Also a given statement. And then last, IT is parallel to ER. It was given. And then from there, we marked angle LTI as congruent. So LTI as congruent to angle TER. So we marked them congruent because of their relationship, because they were corresponding angles. So because they were corresponding angles. All right, so last, we want to prove that we, proved our triangles are congruent. We used an angle which was this one. So we got that angle written. The side was written, it was LT is congruent to TR. I know it's going to be written in a weird order, but that's okay. We knew at the beginning it was angle, side, angle. And then the last thing was that LTI was congruent to ERT. So we did write out all of our reasons. So we have proven that the triangles are congruent by the angle, side, angle theorem. I know this throws people off. It doesn't matter what order you write the givens in, so you could have switched them if your eyes don't like the way we wrote it. It is still angle, side, angle because of the picture. We're going to skip this one, so go ahead and put an X over it. It's a little more complicated than what we'll see. We're going to move to number 9. Number 9. So we want to draw on the picture. We got BA is congruent to ED. So BA is congruent to DE or ED. And then this next one, C is the midpoint. So C is the midpoint. If it's the midpoint, that means of BE, that means BE was cut in half. So BC is congruent to CE. It's also the midpoint of AD. So that means AD was cut in half. So AC is congruent to CD. So right away, we could prove this by side, 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 which we will. But you could have also proven it by side angle side because of vertical angles. But if you notice, they didn't use an angle as a reasoning, so we're not going to use side angle side. But if we were writing our own proof instead of filling in theirs, you could have also used side angle side to prove they were congruent. So starting with BA is congruent to ED, that was a given. C is the midpoint, again that was given. Alright, and then BC being congruent to EC. Okay, we did that because of the definition of a midpoint. Alright, definition of a midpoint is that it cuts a segment into two congruent halves, so we have two congruent halves there. And then AC being congruent to ED, so AC is congruent to, oops, sorry, I read the wrong letter. AC congruent to DC, again, is because of the definition of a midpoint. And then last, triangle ABC is congruent to triangle DEF. We proved that by listing a side, and a side. So we proved it by side, side, side theorem. So we'll stop there with the proofs. Thursday I'll finish this with you and do 11 and 12 with you. Right, this was 9. I don't even think I see a 10. So I'll do 11 and 12 with you on Thursday, so you can practice those together. This worksheet, missing information worksheet, is due on Thursday also. So essentially, you are wanting to prove side, angle, side, and you need to list what else has to be congruent in order to have side, angle, side. On the worksheet, there's all 5 theorems, so something is missing, either angles or sides. So you want to figure out what you do have. We have a side congruent to a side. We got that going for us. And then we have another side. It's the side that they share. So we are missing an angle, and it's got to be a very specific angle because we have a side and a side. We need the angle in between the two sides. So we're going to name that angle. We can't name it angle F because there's 2 angles at F. So we could say EFG, because remember EF has to be in the center, It is the vertex. And it needs to be congruent. In our other triangle, we have FQ is congruent to FG, so the angle also needs to be there at F. Angle GF, no. So I stopped because it's not going to be G first. I said E first, and E corresponds with Q. So it'd be QFG. So this is the additional information that's needed in order to prove these are congruent by side angle side. So you're going to get that worksheet. It will tell you the theorem above. You need to figure out what you have and then list what you're missing in order to have that congruent statement. And again, it is due on Thursday. I'll leave this up here, again, just so you know when things are due, in case you have any questions. You do have a quiz tomorrow. You should be given a worksheet. It's not graded, but it is for your own review, and you need to look at the answers there stapled to the back so that you can check your work.